Hi students, today I am coming with another one question from 2025 CBSE paper. Question number 19, paper code is here 5562. Question number 19. A laser beam of wavelength 500 nanometer and power 5 milliwatt strikes normally on a perfectly reflecting surface of area 1 millimeter square of a body. It rebounds back from the surface. Find the force exerted by the laser beam on the body. This is the question. We can start the theory part first, because you should know some theory or the background knowledge required to solve this one, right? So laser beam related energy calculation you should know, force exerted by the laser beam you should know. Such things we are going to discuss now. The first part we are going to write one we know statement. Okay, so we know that the power is equal to, we did this one in another one question in other way, like power of laser beam is equal to, okay, what is that one is energy of each photon into number of photon, that will be the power delivered by the laser beam. So power of laser beam is equal to energy of photon into number of photon. So we want to calculate first number of photon. To know that one, first write use the variables. So P is equal to E into N. As usual, the P representing power, E representing energy, N representing number of photon. So N is equal to P by E. Then we recall one basic equation. Energy is equal to H nu. E is equal to H nu. And also you know that C is equal to nu lambda, right? From there you can write nu is equal to C by lambda. Now we substitute here with the energy equation. So E is equal to, instead of H nu, this will be H C by lambda. Okay, that is one expression we are going to use in the next step. And also you studied de Broglie wavelength. Lambda is equal to H by P. Famous, right? Lambda is equal to H by P. From there you write what is P is equal to. Remember here P is momentum, not power. Okay, so P is equal to H by lambda. Okay, now we have two equations, one for N, number of photon, and other one is for energy, and one more, P is equal to H by lambda. Now let me rewrite this one. N is equal to P by E. This time in the place of energy we are going to substitute that one. So P, the power divided by Hc by lambda, and H by lambda we wrote above, right? H by lambda is equal to P, that is the momentum. So the expression will be number of photons emitted is equal to P, that is power divided by, in the place of H by lambda we are going to put small letter p here. This blue color one is small letter p, into C. Now number is ready. The number of photons emitted is ready now. P, the power divided by PC. The numerator P is the capital letter P, that is the power. Denominator P is the small letter p, that is the momentum. Okay. Now we go to one more theory. What is that theory is, we want to know how to calculate force exerted. So when a laser beam hit an object or a wall and bounce, then how will be the change in momentum, and based on that change in momentum we will be calculate how much force will be able to exert. Okay, so this is the statement, perfect reflection statement it is. Okay, so perfect reflection statement is for a perfectly reflecting surface. Okay, so a photon hitting normally, that is just hit without making any angle, that is making angle 90 degree with the surface. So a photon hitting normally reverses its momentum. So going that time there is a momentum P, and coming back there is one more momentum P. Now the change in momentum we will write. If you remember the pressure exerted by a gas, the similar expression was there that time, calculation of change in momentum. So the change in momentum per photon is delta P. We use the letter delta P. Delta stands for change. So delta P is equal to 2 into P. P stands for momentum of the photon. Why we are doing this one is, the actual question is The actual question is calculate the force exerted, not the number. But we need this number, then only we can calculate the force exerted, because we want to calculate force exerted by all the photon, not one photon. One photon equation is simple. Force is equal to rate of change of momentum, right? Force is rate of change of momentum. Newton's second law, that one. So number of photon emitted is equal to N is equal to P, the power divided by PC. P, denominator P stand for momentum. Okay, C stand for speed of light. And change in momentum is delta P is equal to 2 into P. I showed you just now above. Now we are going to substitute now what is force is equal to. Okay, normal force equation we are going to write. The sentence, force exerted by photon F is equal to number of photon, how many are there, multiplied by, so number of photon into change in momentum. Okay, change in momentum is there two lines before, that is 2p, and number of photon we already did before. You remember, capital letter P divided by momentum into C. So going to substitute now. F is equal to capital letter N, stand for number of photon into delta P, representing change in momentum. So this is the time to substitute the values. So numerator P, power divided by PC, that is momentum into C, into change in momentum value 2P. Now we can cancel what is there on numerator and denominator, same data. So P and P going to cancel now. Okay, cancel. What left now? F is equal to 2 into P, power divided by C. Now the value given in the question, actually the power is equal to 500 milliwatt. So 2 into 500 milliwatt we are going to write in SI unit, that is 5 into 10 raised to minus 3 divided by the speed of light. C stands for speed of light. 3 into 10 raised to 8. So 2 into 5, 10, 10 divided by 3. The answer will come 3.33. Then 10 power adjust, minus 3 and minus 8, it will be minus 11. Okay. If you have any question or topic you want to explain to you, just post your question or the topic in the comment box. I will mediate on it. Thank you for watching. Have a